So we talked about the terms. In the introduction, we talked about the terms that are commonly used. We talked about the laws of probability. Under the laws of probability, this is a very important area that we always need to remember. We have the addition. We have the addition law, and we say for the addition law to be applicable, we are going to apply it in mutually exclusive events. This law is applied in mutually exclusive events. Those events which cannot take place at the same time. Those events which cannot take place at the same time, when we are computing the probability, we normally use the addition rule. And in this case, it is where we use the conjunction or. Anytime we use the conjunction or, we are applying the addition rule. And the addition rule, we said, if you're talking about probability of A or B, we said the same as probability of A plus the probability of B. We add. That is why it's known as the addition rule. Then the second law we know is about the multiplication. The multiplication law. This one is applicable for independent events. Those events which are not related, the happening or non-happening of one event does not affect the happening or non-happening of the other event. We normally apply the multiplication law. And in this case, we normally use the conjunction and. Whenever we are using the conjunction and, we normally multiply the probability of those events. So the probability now of A and B is going to be the probability of A multiplied with the probability of B. When we are using and, we multiply the probabilities. We multiply the probabilities. Then after this, I also talked about the decision trees. And the decision trees, I said, it is the pictorial presentation of events and their probabilities. The pictorial representation of events and their probabilities. So here and now, I want us to go through the questions that I gave you to try and assist you in solving them. The questions from the past papers. The diploma quantitative techniques past papers. We shall start with the question that I shared today, which is the question for the March 2025 series. In the March 2025 series, the question on probability was question 3B. Question 3B. Quantitative techniques, March 2025, was talking about probability. In this question, you are told that in an office, there are 10 employees, out of which 4 are female. So the female employees, there are 4 out of 10. So the probability that a female will be picked there would be 4 over 10. That is what you need to understand. If there are a total of 10 employees and the female are 4, then the probability of picking a female employee would be 4 over 10. The male employees in that office, therefore, if the female are 4, the male would be 6 employees, so that 4 plus 6 would give us 10. So the probability of picking a male employee would be 6 over 10. That is the starting point that the students needed to comprehend. Then now you are told that 2 employees are picked at random from the office, one at a time without replacement, to represent others in a committee. So we are picking 2 employees, one at a time without replacement, so that the 2 can represent the others in a committee. Then the first part you are told is to represent this information in a tree diagram. So it is very simple. A tree diagram would be constructed in this manner. We are picking 2 employees. the first employee can be either male or female. It can be a male or female employee. What is the probability that we are going to pick a male? 6/10. What is the probability that we are going to pick a female? 4/10. That is when you are picking the first person. Remember, we are picking two. So the first picking, it is either we pick a male or a female. The probability of picking a male is 6/10. The probability of picking a female would be 4/10. After you have done the first picking, remember, you are going to pick again. You are going to do the second picking. The second picking will either be male or female again. If the first one was a male, the probability that the second one will also be a male, remember you have already removed one male. You chose one male from this particular branch. The person that we picked in the first picking was a male. So how many male employees are remaining in that office? Obviously, if we have removed one male, the remaining number of male employees will be 5, and now the total will be 9. 5/9, because already one employee is removed who was a male. So the remaining will be 5/9. What will be the probability that the second employee that will be picked will be a female if the first one was a male? Remember, if the first one was a male, the second one being a female now, remember already one employee is picked, and the employee that was picked here was a male. So the female, they were 4. And what we picked in the first picking was a male. So the females are still 4, but because one male is already gone, it will be over 9. It will be over 9. They are still 4 because what we picked here is female. So the was male, sorry. So the females have not been deducted. They are still 4 because the person who we removed here was a male. So the females are still 4, but because one is gone, the total is not 10 anymore, it is now 9. We go again here. If the first one was a female, the second one can also be a male and or a female. So you look at what you removed. We removed a female employee. So if the first one was a female, what is the probability that the second one will be a male? So we have removed one female. We have not affected the number of male employees. So the male, they are going to be 6, but now over 9. The probability that the second employee to be picked will be a male will be 6, because what we removed here was a female. So the male are still 6, and the total now that one is already removed is going to be over 9. You come here to the other branch. If the first one was female, what is the probability that the second one will also be a female? So already you need to know that one female is already removed from the office. They were 4, now the remaining is 3. After removing one female, the total will be over 10. The total will be over 10. So that is how the tree diagram will look like. And the condition is that we are picking without replacement. So we shall be having -1.
Excuse me, is it 9? Is it 3 out of 9 or 3 out of 10?
9, you are right, Adam. Out of 9. You need to remember that when you are doing the second picking, everything will be over 9. It will be -1 because already 1 is removed. That is what part 1 of the question was asking. So here you can now give a summary. This is a male and a male, so you can put here MM, male, male. What about here? The first one is male, the second one is female. You can put it here as MF. This one is female followed by male. This is FM. Then this one is female, female. We can put it as FF. Summary. This is the probability of picking male, male. Male, then male. Male, then female. Female, then male. And female, female. That is the tree diagram. Roman 2. Probability that you determine the probability that Part 1, all employees selected are female. We are talking about female. The two of them, both of them are female. The probability of female, it is going to be equal to what? You multiply the probability in that particular line. Female first time, 4/10 times female the second time, 3/9. This one will be 12 out of 90, which you can simplify. I think by 4. You can simplify that. You can place it in your calculator. 12/90, 2/15. Roman 2. The probability all employees selected are male. That is the probability of picking male. The first to be picked is the male. The second one to be picked is also male. We are now talking about that line. So this one will be equal to 6/10 multiplied by 5/9. This one will be 30 divided by 90. This is the same as what? 1/3. 1/3. Common 3. The first employee selected is a male. The probability that the first employee to be selected will be a male. So you go to your analysis here. You find where the first one is male, where M is coming first. Here we have MM, so that one is one of them. This one is male, female. So as long as the first one here is M, so we have got two scenarios. Probability that the first employee to be picked is a male, we have got two possible cases. Either it is a male, then the second one is a male, as long as the first one here is a male, here also. So this is the same as probability of male, or probability of male, female. It is either this or this. We are using or here because it is one of these two possible cases. So this one for male, it is 6/10 times 5/9. We say anytime we are using or, we use the addition. We are now talking about mutually exclusive events. Or you put a plus. MF is going to be 6/10 times 4/9. So you have got two possible cases whereby the first employee to be picked is a male. It is either male or male, female. And that is why now the rule of probability of addition is going to be applicable. So you can work out, this one is the same as what you got here, 1/3 plus, this one is going to be equal to 24 divided by 90. 24/90. 6 times 4 is 24/90. 4/15. Plus, the answer will be 3/5. The answer is 3/5. The probability that the first employee to be picked is a male. It is either the first one is a male, then the second one is a male, or a male, then a female. These two, we don't consider them because the first employee to be picked is not a male, is a female. So only these two will be considered by the fact that the first one to be picked was a male. So it is either we are going to have this scenario or this scenario. When we are going to have or being the conjunction here, we now use the addition rule. No male employee is selected. If no male employee is selected, then it means that both of them are female. The two representatives are both female. So we are talking about FF. We are talking about the probability of female, which is the same as this one, which is the same as 2 over 15. The two of them, both of them are female. Lastly, Roman 5. At least one of the employees selected will be male. At least one. The word at least one, it means that the minimum of one. Either we have one male or two males. And actually, in this case, when you have a tree diagram, you only go to where you have got M. Here, male, at least there is one male there. Male, female, there is one male there. Female, male, there is one male there. As long as a male is appearing in that combination, then that one is a probable or possible kind of a probability that we are looking for, or possible or the favorable event. So it is either this or this or this. So at least one male, there is a one male here, there is one male here, there is a male here. So this is the same as probability of MM plus probability of MF plus probability of FM. Those are the possible favorable events. So this one MM, we already have it here, 1 over 3. MF, we have computed here, it is 3 over 15. Plus FM, 4 over 10 times 6 over 9. FM. Four over 15. You get it is going to be 4 over 5. There is a possible way you can get this. Anytime you are asked about at least one, the probability of at least one, there is another way you can compute it. You can simply say probability of at least one is going to be equal to 1 minus probability of female. If you are talking about a probability of at least one male, it is 1 minus the probability of what is not going to be a favorable event. Remember, we have talked about this and this and this. This one was not part of it. And we know the sum of all the probabilities must be equal to 1. So it is 1 minus the probability of what is not going to be a favorable event. 1 minus this, because this one is not among the favorable events. So you can do 1 minus the probability of FF. Probability of FF was what? Probability of FF was 2 over 15. Probability of FF. Just a minute. I want to look at what I've done here. Male is what? Male was 1/3 plus male female. Male female 6/10 times 4/9. Male female is 4/15. Male female MF 6/10 times 4/9. 4/15. Female male. Female male 4/10 times 6/9. It is also 4/15. Yes, I think here I've done it wrong. The answer is 13/15. You just work out this male, it is male times male. You get it is 1/3. 6/10 times 5/9. Then we have male, female. Male, female, it is 6/10 times 4/9. It is 4/15. Then you work out female, male. Female, male, this and this is again 4/15. So if you do this plus this plus this, you get that. Remember, you can do direct with your calculator. In your calculator, there is somewhere written AB/C. This icon is over. It is AB/C. This icon means over. So if you want to do this, like for example, you want to do 1/3 plus this plus this. So you just press 1, then AB/C 3. This means 1/3. Plus, if you are doing 4/15, you press 4, AB/C, and then put 15. This is 4/15. Plus, if you are doing this again, you say 4, AB/C 15. You can do it once. I hope you can be able to do that in your calculator without doing divide. 1/3 plus 4/15 plus 4/15. You get that. So when you do this, 1 minus 2/15, you will still get 13/15. You will still get 13/15. You still get your 13/15. So you can use this approach or that approach. It will give you the probability of at least 1 male. If you are told probability of at least one female, you can do now 1 minus the probability of both male. When you are told the probability of at least one female, 1 minus the probability of both males. So that is how the question was supposed to be handled. So after having done that, let us go now to the questions that I gave you. The questions that I gave you. Last week. QT past papers. So the first question that I gave you was on page 3. Page 3. That is a question for November 2022. November 2022, page 3. That is question 3B. Question 3B. And it says that a factory uses 3 machines. We have 3 machines that produces the items. We have machine J, K, and L. Then you are told that machine J makes 35%. Remember, probability can also be expressed as a percentage. So probability that an item is produced, probability that an item is produced by machine J is that 5%, which is 0.35, because it can produce that 5%, meaning that the probability that an item or a unit is produced by J is the same as that, 0.35, that 5%. Probability that an unit is produced by K, K can produce 40%, which is 0.4. Then, and the rest are made by L. So if you add this, remember they are supposed to add up to 100%. 35 plus 40, that is 75. So the remaining percentage is now the probability that the units will be produced by L, which is 0.25 or 25%. So that is one thing that you needed to interpret. If this one can produce that 5%, then the probability that an item is produced by J is that 35 over 100, which is the same as 0.35, 40 over 100, which is the same as 0.4. This is the same as 0.25. Remember, probability cannot exceed 1. Then it goes on to say that it is known that 5% of the pens made using machine J are 40. So probability that it is produced by J and it is faulty J and 40 is the same as 5%, which is the same as 0.05. Probability that a pen is produced by K and it is faulty will equal to what? Probability that K produces a 40 3% of K. 0.033%. Probability that it is from air and it is faulty is going to be equal to 2%, 0.02. You change those percentages to be your probabilities. A pen is produced by J and it is faulty is that. Then now you can go to the question and answer them. A pen is selected at random, calculate the probability that a pen is made using J and it is not faulty. If it is faulty, is this probability that it is not faulty. Not faulty, we said what? We said the probability of something happening plus the probability of the same thing not happening must add up to 1. So if the probability that the item is faulty is 0.05, what is the probability that it is not faulty? It is 1 minus this. You take 1 minus the probability that is faulty so that you can get the probability that it is not faulty. So you take 1 minus this, 1 minus this, 1 minus this to get the probability of not faulty. You get this one is 0.95. Probability of not faulty will be 0.97. Probability of not faulty is 0.98. 1 minus this. Then with that, now you can answer those questions comfortably without any problem. So if you are given the probability of faulty, the probability of not faulty is 1 minus that probability. I gave you and I told you that probability of raining and probability of not raining should add up to 1. So if you are given one of them, to get the other is 1 minus what you have been given. So Roman 1, we are told we determine the probability that a pen is made by machine J and it is not faulty. Probability of J and not faulty. You multiply. When it is and, you multiply the probability. Probability of J is 0.35 times the probability of J not faulty, 0.95. Work out that, as simple as that. The probability that it is made by J and the probability of not faulty. Don't use the faulty. We are told not faulty. Norman 2, the pen is faulty and it is made using either machine K or machine L. 1, it is faulty and it is made using either K or L. So probability of faulty, let me use the start K and faulty, or probability of L and faulty. That is what it says. Probability that it is faulty and it is from K or L. So it is from K and it is faulty, or it is from L and it is faulty. You will come here, K and it is faulty, 0.40 times 0.03. Because of this and, we multiply. Or means we add. Probability that is from L, which is 0.25, times it is faulty from L, 0. Work out that, you get the answer. K and 40 or P and 40. Last 3, Roman 3. The pen is made using machine R and is faulty. Probability that it is from R and it is faulty. It is only this part. Now work, it is 0.25 times 0.02. You multiply them and you get the answers. So for the part 1, 0.35 times 0.95. You get 0.3325. For this one, you can put the bracket 0.40 times 0.03. You close the bracket, then you say plus, open the bracket, 0.25 times get 0.017. This one is going to be 0.005. And that is how simple it is. You interpret this first, then coming here, just picking the probability. J and faulty, P not faulty like that, but you need to make that analysis there. Then it is just going to be a matter of multiplying or adding. The rows of probabilities must be applicable. After question 3, we go to question 9, to page 9, sorry. On this page 9, this is on November 2021. It was question 1A. A question that came in November 2021, quantitative techniques, question 1A. The probability that a train arrives on time at terminus A, probability that it is on time at terminal A, it is 5/6. This is the probability that is on time. If you are told that the probability that it is not on time, you can use that. Not on time in terminus A, it is going to be 1 minus this. 1 minus 5/6, which will equal to 1/6. If you are given the probability of something, the probability of the same thing not happening, you do 1 minus that. Probability that it is going to be on time in terminus B, we are told it is 3/4. Meaning that probability that the train will not be on time in that terminus, it is 1 minus 3/4, which is again going to be 1/4. You should be able to interpret that. Before now you go to the questions. Determine the probability that the train arrives on time on both A and B. Probability that is on time on A and B. It arrives on time here and arrives on time here. Because of and, we multiply the probabilities. The probability that is on time in A, it is 5/6, times the probability that is on time in B, it is 3/4. Get the answer will be 5/8. That is Roman 1. Roman 2. On time in one of the terminals. It is on time, not on both, but one of them. So this one, we are going to have two possible scenarios. It is either on time on A, but when it comes to B, it is late. It is on time only in one. So it is either on time here, but late here. This is the same as probability of A on time and B not on time. Then we are going to have another case, or it is on time in B, probability that is on time in B, and rate in A. Rate in A is 1/6. It is on time in one of them. Remember, it must move from the two terminals, or it must arrive at the two terminals, A and B. So it is either in A, it is on time, in B, it is not on time. B is not on time. So A is on time, 5/6, and B is not on time, 1/4. Or that is addition. It is on time in B, 3/4, but not on time in A. Not on time in A is 1/6. This is going to be 5/24 plus 3/24. This is going to be 1/3. It is on time in one of them. So it is on time in this one, the other one is late. Or it is on time on the other one, but this one is late. So you are going to have that case or that possible two scenarios. In A, it is on time and B not on time, or it is B on time, A not on time. That is the probability that it's going to be on time in one of the terminals. Last three, Roman 3. It is late on both terminals, meaning that it is late here and late in B. Late in A, probability that it is late in A and late in B. It is late in both terminals. So you multiply the probabilities of being late, which will be equal to 1/6 times 1/4, which will be 1/24. And that question is done. There is a question that you are also trying on page 36. Page 36, that is November 2016. November 2016. That is question 5B. A supplies management class is made up of 15 boys and 10 girls. Boys are 15, meaning that the probability, let me first of all capture the number of girls in that class of supplies management. They are 10. So the total students in that class is going to be 25. 15 plus 10. So probability that a boy is going to be picked from that class will be 15 out of 25. Probability that a girl is going to be picked from that class is 10 out of 25. Make that breakdown. Then you are told that the club, we are forming a club of 3 officials. Determine the probability that the club officials are all boys. This is like the same case of picking without replacement. We want 3 people to form a club of 3. So it is like you are picking 3 students so that they can form that club or that club of officials. So the club officials, the probability that all of them are boys, all of them are girls. So you can draw a tree diagram. You can also work without a tree diagram. Let me do it in a tree diagram. So either you pick, you remember you are picking 3 officials, boy, girl. That is the first picking. The second one can also be boy, girl. boy, girl. Then you pick the third one, boy, girl, boy or girl. This is girl. Boy, girl. Then you finish boy, girl. You need to have 3 arms. Huh? You need to spread them. So this is the first picking, the second picking, the third picking. Yeah? So remember, there are a total of what? 25. So when we are picking the first time, the boys are 15, so the probability is 15 over 25. The girls are 10, the probability is 10 over 25. When we are doing the first picking. Then you come here, if the first one who was picked was a boy, the second boy to be picked will have a probability of 14 out of 24. Eh? If a boy is already picked here, the remaining boys are 14, the total is -1 over 24. What about the probability that the second to be picked is going to be a girl if the first one was a boy? Remember, we have not picked a girl, so the number of girls are still 10 out of 24 because already one boy is picked. Come here. The first one is a boy, the second one is a boy. What is the probability that the third one will also be a boy? 2 boys are already picked, so from 15, we are remaining with 13 out of 23. You remove 2 from the 25. You get 23. Here it's a boy, it is a boy. So we have not eliminated any girl. The girls are still 10 out of 23. You come here. This is a boy followed by a girl. So we have removed 1 boy. If they were 15, 1 is removed here. They are remaining 14 out of 23. We have removed 2. What about here? This is a boy followed by a girl. What is the probability that a girl would be picked as the third? So a girl is already picked here. If they are 10, now they are 9 out of 23 because we moved 2. You just look at what happened before. Here, the first one was a girl. What is the probability that the second will be a boy? So the boys, we have not removed any boy. They are still 15, but because 1 girl is taken, we do over 24. The first one is a girl, so we minus 1 girl. They are now remaining 9 out of 24. We are determining the probability here of picking the third student being a boy. So if it was a girl, 1 boy is already taken. So if they were 15, 1 is taken out, they are remaining 14 out of 23. The first one was a girl, second one a boy, the third one now, the probability that it will be a girl, already 1 girl is eliminated. If they were 10, they are now 9 out of 23. What about here? Boy, girl, girl. So we have already removed 2 girls. We have not removed any girl along that line. Any boy, sorry. No boy has been removed in this line. The first one was a girl. The second one is a girl. So the boys are still 15. But now that 2 girls are taken, it is over 23. Girl first time, girl second time. So already 2 girls are taken out. From the 10, we remove these 2. We are going to remain with 8 out of 28. If we were to do a tree diagram, that is how it will look like. You look at what has been removed, you minus that. This is the probability of boy, boy, boy. Boy first time, boy second time, boy third time. What about this one? Boy, boy, then girl. BBG. What about here? It is boy, girl, boy. What about here? Boy, girl, girl. What about there? Girl, boy, boy. What about here? Girl, boy, girl. What about here? Girl, girl, boy. Here it is girl, girl, girl. With that summary, now you can answer your questions very fast. Roman 1, probability that all are boys. We are talking about this combination. Probability of BBB. That one I'll leave you to work it out. 15 over 25 times 14 over 24 times 13 over 23. That is the boy, boy, boy. Boy the first time, and a boy the second time, and a boy the third time. Roman 2, two of the officials are girls. So you simply go to where you have got two girls. So here there is no girl, so this one is not important there. Here it is only one girl, it is not important. Here it is only one girl, not important. Here we have got two girls, so this one is going to be a favorable event. Probability of two girls. So we have got one, it is probability of BGG, or we have another one, two girls. This one is not important because it is two boys. This one is two girls, GG. Probability of GBG. Plus, this one is important, this one, GGB. You only go to the combination where you have got two G's, because we are talking probability of picking two girls. Either we pick this combination or this combination or this combination. As long as we have got two G's, you can work it out. So you simply go to that root. BGG, it is here. 15 over 25 times 10 over 24 times 9 over 23. Add GBG. GBG, it is this one. So you go that root, 10 over 25 times 15 over 24 times 9 over 23. Then you add this one, is also a favorable event. 10 over 25 times 9 over 24 times 15 over 23. You add them. You multiply them, then you add them. Probability of two girls. None of the officials is a boy. None of the officials is a boy, so you only work with this. All of them are girls. It is the same as the probability all of them are girls. The probability of GGG, that is Roman 3. The probability no boy is the same as the probability of all girls. So it's the same as the probability of GGG. So that is your work to complete that. Page 44. Page 44, that is July 2016. July 2016. The question is 5B. An employee may use his personal car. You are told the employee can use a car. This is personal car. You can use public transport, or you can travel by foot to work. Going to work, you can use personal car, public transport, or foot. The probability of using the three modes of transport is 3/2. The probability for this is 0.2. The probability that you will use a car is 0.2. The probability that you use public transport is 0.4. And this one is 0.2 as well. The probability of being late for work using the three modes of transport is 0.1. If uses the car, probability of being late is 0.1. Meaning the probability of not being late is 0.9. 1 minus this. So that is what we have said. If you have given the probability of being late, the probability of not late is 1 minus that. The probability of being late here, if it uses the public transport, is 0.7. Meaning the probability of not being late is 0.3, 1 minus this. The probability that is going to be late when he uses his feet is 0.5. Probability of not being late will also be 0.5, 1 minus that. With that, now you can be able to actually work out what you are being told. You are being told, present the information using a tree diagram. Go like this. This is going to be your tree diagram. Our tree diagram, we have got three modes of transport. This is car, this is public transport, this is foot. The probability is 0.2, 0.4, 0.2. If he uses any of these, there is chances that the person will be late or late not. If he uses this, he can arrive at work either being late or late not. Let me use that apostrophe. You can either be late or late not. You use those probabilities. If you uses the car, being late is 0.1, not late is 0.9. Late, not late. This one being late is 0.7, not late is going to be 0.3. Foot being late is 0.5, not late is 0.5. That is your tree diagram. That is your tree diagram. You have got three modes of transport. The probabilities are provided. Any of those, you are either going to arrive at work late or not late. Put those probabilities. That is how your tree diagram will look like. Then now, using your tree diagram, you can be able to work out this. Determine the probability that the employee will not be late for work. The probability of not being late. Probability of not being late. So you are talking about not being late. Late, not late, not late, not. So this one, it is either you use a car, not late, a car and you are not late, 0.2 times 0.9, or the employee uses public transport and not late, which is 0.4 times 0.3, He uses foot and not rate plus 0.2 times 0.5. So that is the probability of not being late. Either uses the car but is not late, or you use plus, or is addition. He uses public transport and not late, or he uses food and not late. You add them, you are done. The last question, I'll just give you a breakdown so that we do one distribution. The last question was page 50. Page 50 is November 2015. Page 50, it is a question for November 2015. The question is question 4A. Question 4A. The contents of 3 food baskets at Mama Awinja groceries are as follows. We have 3 baskets, first basket, second, and third. The fruits are either mangoes, apples, or oranges. And then you are told that a fruit basket is picked at random and 2 fruits picked from it randomly, one at a time, without replacement. The 2 fruits picked were an apple and a mango. Determine the probability that the 2 fruits picked were picked from the second basket. So remember here we are talking about 3 baskets. So you have basket 1, basket 2, basket 3. The tree diagram must be one continuous. Don't draw tree diagrams that are different for each. So this is the first basket, this is the second, this is the third. And because there are 3, we are not given the probability. When you are not given the probability and you have got 3 outcomes, each will have a probability of 1 over 3. There are 3, so each will have a probability of 1 over 3. We have 1, 2, 3. So 1 over 3 is the probability of picking any of the basket. Then inside this, we are having what? Inside this, we have got mangoes, apples, and oranges. Mangoes, apples, and oranges. Mangoes, apples, and oranges. So look at basket 1. We had 1 mango, 2 apples, and 3 oranges. So you do the total. 1 plus 2 plus 3, those are 6. So for the mango is going to be 1 over 6 probability. For the apple will be 2 over 6 probability. This one will be 3 over 6. For the second basket, we have 2, 3, 1. That is also 6. So this one will be mango, apple, oranges. So for the mangoes, there are 2, 2 over 6. Apples, there are 3, 3 over 6. Oranges, it is 1, 1 over 6. For the third basket, there are also 6. For the mangoes, apples, oranges. So it is 3 over 6, 1 over 6, 2 over 6. Thus, it is the first picking. This tree diagram is going to be so big. But nobody told us to do the tree diagram. But anyway, let us move on. That is the first picking. Then the second picking in each. Because we are told 2 fruits are picked. 2 fruits are picked. Let me not dwell on this. Let me concentrate on the second basket because that is where we are told. We are told 2 fruits are picked. The 2 fruits picked were apple and mango. Determine the probability that the 2 fruits were picked. The 2 fruits picked were from the second basket. Let me deal with the second basket. So mango, apple, orange, mango, apple, orange, mango, apple, orange. So if the first one was mango, the second one being a mango, remember we have removed 1 mango. So how many mangoes are remaining? 1/5. Huh? The first one was a mango. What is the probability? The second one would be an apple. Apple, remember there were how many? There were 3. So they are going to still be 3/5. Oranges, it was 1 orange. If the first one was a mango, then the probability that the second one will be an orange will be 1/5. It is only the mango that will reduce by 1. The others, they remain to be 3 and 1, but now it will divide by 5 because 1 fruit is already picked. The first one was apple. What is the probability that the second one is a mango? Remember mango, there were 2. They're still going to have a probability of 2, but over 5 because 1 apple is gone. Apple, there were 3, 1 is gone, so it is 2/5 as well. Orange, it is an apple that has been taken out, so it is 1/5. Still like that. Then probability for this one is now orange. The mango will be 2/5. Apple, they were 3, they remain to be 3/5. This one, the probability will be 0. Eh? 0 in the sense that it was 1 and we have already taken it. So it has no chance of being picked. The probability of picking an orange is 0 because already it was 1 and it has been picked from there. So what is the question asking? The probability that 2 fruits were picked 1 at a time without replacement. The 2 fruits picked were apple and mango. Eh? Apple and mango. So what is the probability? Look here. This is what? Mango, mango. This is mango, apple. This is mango, orange. This is apple, mango. Apple, apple. Apple, orange. What about this one? Orange, mango. Orange, apple. Orange, orange, which is 0. So we are told what is the probability. Remember the fruits that were picked, they were apple and mango. So you only go to where we have mango and apple. Eh? Apple, mango. So those 2. Where there is a mango and an apple. Mango, apple, mango. Eh? This. And remember that is from the second basket. That's why I was not interested with this. Because the 2 fruits that were picked, they were from the second basket. So what is the probability of mango, apple, or probability of apple, mango? To multiply those kind of cases. Remember, it is the second basket, so you do 1/3, the probability of second basket, times the probability of mango here, which is 2/6, times the probability of apple, which is the 3/5. Must start with the probability of picking the second basket, 1/3. Or you put plus probability that is the second basket, 1/3, times the probability of an apple, 3/6, times the probability of a mango, 2/5. You work out that. So you only concentrate with the second basket. But this one, you can do it without a tree diagram because it was not a requirement. You do a tree diagram. We only did it so that it can make our work easier and our understanding better. Find more questions on probability. Even now on the other questions on quantitative methods. Remember, I sampled this one from quantitative techniques. Look for the second set of questions from the quantitative methods. Past papers that I shared with you, you try work out. But that is how you reason out. That is how you reason out. I want to spend like 15 minutes so that I can take you through one of the probability distribution that is commonly tested. The topic is probability and probability distribution. There is one very common probability distribution that is normally tested in your exams, and that is the normal distribution. Normal probability distribution. Normal probability distribution. And this one is related to what we call a normal curve. When we talk about a normal curve or a normal distribution, it is a distribution that has got that shape. That is a normal distribution curve. It is going to be symmetrical. Meaning that if we cut it here to the center, we have got two equal halves. This one and this one. The probability of a normal distribution curve, the probability is normally equal to 1. The probability of an area below the normal curve is normally 1. So this area that I'm shading here, it is normally equal to 1. So meaning that if it is 1 and this one is a normal curve, then this side will have 0.5. This side will also have 0.5 from the center here. Yeah? From the center here, this is 0.5, 0.5. The mean is normally 0 here. There we have a 0, the center. So that if you add 0.5 plus 0.5, you get 1. You get 1. And anytime you are told to determine probability for normal distributions, you will be required to calculate first of all what we call the z-score. And the z-score is calculated by x minus the mean all over the standard deviation. So x here is the value of interest, what we are interested with. This one is equal to the mean of the distribution. This one is the standard deviation. You calculate the z-score. After calculating the z-score, we are going to use the normal distribution table, which will give us the values or the probability to the left of the normal distribution curve. We shall calculate this, we get a value, and that value we go to what we call normal distribution curve. We are going to use the normal distribution table, which we normally call the Z table. This is the table that will give us the probability. The normal distribution table or the Z table. With this Z score, we put in the table, it will give us the probability. It will give you the probability. And this Z score is going to give you the area to the left. And it is very, very easy, very, very easy. Area to the left. I want to demonstrate with only 2 questions. Only 2 questions. It is going to give you the area to the left, and then you look at your interest. So I want you to look at page 5. Before you look at page 5, let me explain something here. When you are looking probability, you can be told the probability of less than. You can be told the probability of having the value between something or more than. Let me illustrate this. So when we go to the question, it's going to be very easy for you to understand. We said the normal curve is going to be like that. This is the center. If you are asked anything to do with the probability that the max or the mean is less than 30, we are going to come here, get the z-score. Our interest will be this area. Actually, it is the same as the z-score that we are going to calculate. If you are told between, let me draw a smaller one. Ukienda hapa, you just ask me and I explain it very fast. For less than, our area we are going to be interested with is going to be this area to the left. That will be the answer. For between, we are going to talk about between 2 values. So our area of interest will be that one at the center. This one is for between. For more than or greater than, our area of interest will be this area to the right. This one is the same as z-score. This one is there. You get the probability by taking the greater z-score minus smaller z-score. This one you get p is equals to, get the probability for this p will be equal to 1 minus the z-score. 1 minus the z-score that we shall get from the table. The greater z-score minus the smaller z-score. This one is the z-score itself. This one is 1 minus the z-score that we are going to get. Okay, let us illustrate with what we have in page 5. Page 5. Our page 5 talks about what? Yes, page 5 is about this. November 2022. This is question 7A. November 2022, question 7A. What are we told? An ICT examination was conducted for 200 students in a college. The marks scored were found to be normally distributed with a mean of 66. We are given the mean is 66. The standard deviation is 5. And then you're told calculate the number of students whose marks were above 68. Above 68. Remember that one is the same as more than. above 68, what you will do, you will calculate the z-score. You say z is equals to x minus the mu divided by the standard deviation. Calculate the z, where x now is the value that you are given there. If you are told above 68, your x is 68. Our x here will be 68. So you will do 68 minus 66 divided by 5. X is 68, mean is 66, standard deviation is 5. So what do you get? 68 minus 66 divided by 5, you get it is 0.4. So you get the z-score. Sorry, I forgot to share the tables with you, which you will normally be given in the exams. You can't do this without table. It is shared. Can you open that table? Those tables are two. We have those with negative and positive. Sorry, Adam, I never saw your chart. Those tables are two.